Good day, everyone. How are you all doing? So today I want us to just start focusing on your analytical geometry from the word go. Great. Now, question number two. Question number three. Yes. Question number three. Stop us anytime. Ask your questions on the comment section. Let's engage. In the diagram below, A, where is A? Oh yeah, here is A. A is -1 is to 4, and B is P is to -2. Where is B? There is B in quadrant number 4. And C and where is C? C is in quadrant number 3. Then also triangle ABC. It also have E, which is the y-intercept, which means that point E is 0 is to y because it's a y-intercept of AB. Check. Now we can also see that we have the midpoint, which is F, which is 0 is to -4, and also that's a y-intercept because we can see that x is equal to 0. Then from there we are given the angles of inclination of AB and AC, that it's 135 and alpha respectively. So for AB we have that 135, then for AC we have that alpha. So definitely we already know where we are gonna start. Let me just go at the end of the paper. There are nice formulas I want us just to be able to be aware first before we can proceed with the whole question paper. So at the back of the question, there are other questions which you don't even have to know formulas of because they're already here. For instance, if we look here, we have our formula y equal to mx plus c. We have d is equal to x squared minus 1 squared. That's the distance formula. We have the midpoint formula. When we have y minus y1 equal to mx minus x1 is another formula which we use to determine the equation of a straight line. Then of course we have the gradient formula where m is equal to y2 minus y1 over x2 minus x1. Then we have the angle of inclination formula which says m is equal to tan theta. Then of course we have our circle, that one which is x minus a squared plus y minus b squared equal to r squared. Then of course in the triangle ABC, then we are now looking at what we call our area rule. We also have that the first one is the sine rule, which is a over sine A equal to b over sine b equal to c over sine c. Then of course we have sine A plus b, sine A minus b, what we call the compound angles, which we were taught in grade 12. So when we are doing trigonometry, always know you don't have to cram them, you just have to know how to apply them because they'll be given for you in the formula sheet. Of course we have our double angle of cos 2a and sine 2a. Cos 2a has 3 double angles: cos squared of a minus sine squared of a, as well as 1 minus 2 sine squared of a and 2 cos squared of a minus 1. Of course for sine 2a we have our 2 sine a multiplied by cos of a. Of course that's so important and so crucial. Then those are the formulas. You don't even have to know them, you just have to be able to know how to apply them because they'll be given for you when you are writing your exam. Of course the mastermind, x is equal to -b plus or minus square root of b squared minus 4ac over 2a. That equation applies for both questions. Usually paper 1 and paper 2, you have to be able to apply that equation there. Let's get down to question number 3, which we have already read down. Now let's analyze the question and answer the questions which we were given in that question. For the first question, 3 points. Let's go and let's start solving our problems. Okay, so we can also see that in this question which we are given, when they say calculate the gradient of AB, which means we have to know that since we are given the angle of inclination, so now we are on 3.1. Since we are given the angle of inclination, now definitely we can have our gradient of AB, which is equal to tan of theta. Okay, then of course what is theta? Then gradient AB is equal to tan of 135 degrees. Then using your Casio calculator, tan of 135, that's -1. So our gradient here is just -1. That's not hard, that's easy because everyone knows how to apply that, and that's that. We are done. We don't have to waste time. It's 2 marks. We are in, we are out there. 3.2, we are given, show that the value of P is 5. How can we show that the value of P is 5? So we can see that we are given the coordinates of B to be P is to -2. Okay, so now they want us to determine the value of P. So how do we do that? So we know that the gradient of AB is equal to -1, and we know that in order for us to calculate the gradient of AB is always equal to y2 minus y1 over x2 minus x1. So we already know the gradient is -1. Now let's substitute there. That will be -2 minus 4 divided by p minus -1. Then we put that in bracket. Of course, we cross multiply. Then we have p plus 1 equal to -2 minus 4. That's -6. Then of course, the scalar multiply -1 multiplied by p, negative times +1. That's -1 equal to -6. Of course, then after that we end up having negative p is equal to -5. Then after that p is equal to +5. As we can also see that point B is in the fourth quadrant, and the x value is positive and the y value is positive. And from there, we can be able to say that, dango, we are done with that. Our value of P is just 5. Now, on 3.3, they say, calculate the coordinates of C. What is C? Where do we see C? That's the important question to analyze. So C is in the third quadrant, and y is negative, as well as x is also negative. So since that's the case, and how many marks do we have? It's also 2 marks, which means this is an easy question to do. So in that question, how do we solve the question there which we have? We know that, of course, in 3.3 we can solve it by saying that 5 plus xc all divided by 2 is equal to 0, and we can say, someone can say -2 plus yc all divided by 2 is equal to -4. Why are we saying that? Because we are given the midpoint. So we are using the midpoint to be able to determine the end point of C. We know the coordinates of B. We also know the coordinates of F, the midpoint. So we can use that to calculate and get the coordinates of C. Someone will be like, I don't know the equation. This is the equation. Xm is always equal to x1 plus x2 divided by 2, and ym is equal to y1 plus y2 divided by 2, where xm is the x value of the x. For instance, we are having our 0 is to -4. So this is the x value of the midpoint, and this is the y value of the midpoint. Then after that, you can make x1 and y1 to be the subject of the formula, or people can make x2 and y2 be the subject of the formula. Then from there, you can be able to calculate and get the value which we want. So in this instance, we just have our 5 plus xc divided by 2 is equal to 0. So x is representing the x coordinates of c. Then also we did the same thing for the other part. So 5 plus xc, then cross multiply, that would be 0 is equal to 0. Then our xc, we can see it's -5, and -2 plus yc is equal to -8, and yc is equal to -8 plus 2. That's where now we get our positive, our -6. Then for instance, now we can conclude that coordinate c is -5 is -6. So it's just easy. It's just more of you analyzing the question on what we are given, so that you can get the proper correct answer. Now, calculate the equation AC in the form y equal to mx plus c. That's easy. What's the first step? The first step is to be able to determine the gradient of line AC. So now we are on 3.4. So on 3.4, the first step is to be able to determine the gradient of AC. What is the gradient of AC? The gradient of AC is always equal to, of course, y2 minus y1 divided by x2 minus x1. Now we know the coordinates of C, so we also know the coordinates of A, that the coordinates of A is -1 is to 4. So now we can calculate the gradient of line AC, so that we can be able to use our equation of y minus y1 equal to mx minus x1. Then from there we are happy. So now let's calculate the gradient. This is equal to what? So calculating the gradient of that will be, we can have 4 minus 6, 4 minus 6. We can put that in bracket since it's negative. Then of course we have -1 minus 5, that in bracket. Then using your calculator, don't try to solve it with your mind. You don't have time. You need to use your Casio calculator. So using your calculator, 4 minus 6 plus 10, -1 minus 5, that will give us 4. So that will be 10 over 4. Then 10 over 4, when you say 2 into 10, that's 5 over 2. So our gradient of line AC is 5 over 2. But we are not done. Now we can now go to y minus y1 equal to mx minus x1. Then now we can substitute if we use the coordinate of A, of B, or B. So if we substitute our A, which is -1 is to 4, then now we have y minus 4 is equal to our gradient 5 over 2, x minus minus 1, then definitely we are happy from that point and we can be able to get a correct answer. So what is important, so crucial, is that we should be able to calculate the proper answer at the proper time. Then definitely y is equal to 5 over 2x. 5 over 2 times positive 1, that's positive 5 over 2 plus 4. Then now we use our calculator to get the final answer. So that will be 5 over 2x, then 5 over 2 plus 4. That should be, again, using your calculator, 2.5 plus 4, that's 13 over 2. So it's 5 over 2 x plus 13 over 2. Then after that, we are happy, we live a happy life. Or someone who wants to just be more simpler or wants to make problems of their life, they can say that the equation will be y is equal to 2,5x plus 6,5, because 13 divided by 2 is 6,5 and 5 divided by 2 is just 2.5. But it's not necessary, you don't have to do that, you can leave it in the way it was initially. Now let's proceed and go to the next question, which we are given here. Calculate the size of CAB. Where is CAB? So we need to calculate that size there. So that's easy, guys, to calculate, because now we can calculate alpha first by because now we know the gradient of AC, so we can calculate alpha. Then of course alpha plus angle CAB is equal to that exterior angle 135. So it's that triangle here where there's alpha going to A, going to that side. So if we add alpha plus that side, it's gonna be equal to the exterior angle of the triangle, guys. Now this is fun. This is fun. So now we are on 3 point. Come on. 3.5. So on 3.5, we say that the first thing is to be able to calculate our gradient. Our gradient of AC we have calculated to be 5 over 2. So tan theta now is equal to, no, it's not theta, it's alpha actually. So it's 5 over 2. Then alpha there will be tan inverse of 5 over 2. Then tan inverse of 5 over 2. Again, we use our Casio calculator. Tan inverse of 5 over 2. Then I am getting 68,198, which is just the same as alpha is equal to 68,2 degrees. Then from that point now, we can literally say that CAB plus this alpha should be equal to 135 point what? What's that? Yeah, it's only 135. Then our reason is the exterior angle of a triangle, because we know that the exterior angle of a triangle is always equal to two opposite interior angles of a triangle. So CAB will be equal to 135 minus alpha. Our alpha is 68.2. Then again, we use our Casio calculator. 135 minus the answer. Then I'm getting 66.80. So this will be our CA0. This was easy because we can literally see, you can just see with your eyes what we have there, and everyone here lives a happy life after that. Now calculate the area of BEF. B, E, and F. Okay, there is there. How can we calculate the area of BEF, guys? So this should also be easy. B, E, and F. Yes. So how can we calculate this, guys? So the first thing is to be able to know what is the coordinates of E, because we don't know the coordinates E. So since we know the equation of AB, or we can determine the equation of AB, then from there we can be able to determine what is the coordinates of E. So this is how we do it. Of course, we start by just writing our E, which is just 4 equal to -1 multiplied by -1 plus C. -1 was our gradient, mx plus C. Then this is a coordinate, which is -1 is to 4. Then after that, we get our C to be -1 times 1 is 1. So definitely our C is equal to 3. Okay. So from there, we can literally see the equation is going to y equal to -1x. So that negative not really important, so we can just say -x plus 3. Okay, so we know that E is the y-intercept, which means it's 0 is to y. So now we just have to say y is equal to -0 plus 3, then y is equal to 3. Then therefore the coordinates of E will be 0 is to 3. That's the first thing which is important. And what is the coordinates of F? The coordinates of F is 0 is to -4. Then from there now we can be able to calculate our area, because the area of triangle BEF is always equal to half base times EF, right? Times the perpendicular height. Okay, then we are happy. Half of what is EF? EF is just going to be the distance of EF, which is equal to square root of x2 minus x1 all squared plus y2 minus y1 all squared. But now, of course, this is just going to be 0. Then 3 minus 4, that's 7. 7 squared is 49. Then square root of 49 is 7. So that's 7 multiplied by our perpendicular height, which is just 5. Then from there, we live a happy ever after. Okay, because we can see that the coordinates of P is 5. Then from there, we use our calculator. 7 times 5 is 35. 35 divided by 2, that's 17.5 square units. Okay, so since they didn't give us meters or centimeters, so we can just write its square units. Okay, then after that, we are happy. Now we can proceed. Now 3.7, another point kt is to t where t is less than 0 is plotted, which means the values of t, they're just negative. Okay, now it's plotted such that ak is that 5 root k. Calculate the coordinates of k. So this one, I want you guys to do it so that you can be able to engage. But okay, since it's today, I'm happy, you're also here. Please just do it together then. Okay, so on 3.7, so we are given our ak to be equal to 5 root of 5. So what do we know? AK is the distance already. So we need to put our distance formula there, which will be x2 minus x1 squared plus y2 minus y1 all squared is equal to our 5 root 5. Bear in mind that the coordinates of A is negative 1:4 and the coordinates of K is T:t. So now we are just substituting. So we have our T minus 1, that's positive 1 squared, plus what is y2 minus y1, that should be our t minus 4 all squared or square root equal to 5 root 5. Then after that, we square both sides, then we remove that. Then we are now having t plus 1 all squared plus t minus 4 all squared equal to 25 times 5, because this is 5 squared, 25. Then root of 5 is just 5. Then we have 25 times 5, 25, 50, 75, 100, 125. So 25 times 5 is 125. Then from there, now we just expand and remove this bracket. That should be t squared plus 2t plus 1 plus t squared minus 8t plus 16 equal to 125. We have removed this bracket so that you can have a proper answer there. Then from there, that will be t squared 2t minus 8t. That's gonna give us something else. Let's check. Yeah, 2t minus 8t there. We should be able to get our answers in a proper way, guys. And definitely we have our negative 3t there. Wait, it's 16. Then 1 plus 16, that's 17 equal to 125, if I'm not mistaken. Then from there, now you guys now just need to solve it and we should be happy after that. Okay, so we have our t squared plus t squared, so that's 2t squared. Then 17 minus 125, 17 minus 125, that's negative 108. So we can just have our negative 108 equal to 0. Then t squared minus 3t, then 108 divided by 2, then that's negative 54 equal to 0. So we divided all through by 2 by 2. Then of course now we can have our factors equal. If you don't know how to find factors, don't worry about anything. Instead, use your quadratic formula. No one at this point should even try to find factors. If you don't know how to find factors, use the quadratic formula so that you can get the correct answers. Of course, in this instance, in order for us to get 54, 6 times 9, it's 54. So we have 9, we have 6, but we need negative 3. So this one must be positive, this one be negative, so that we have 6 minus 3, then we get negative. But if you don't know how to find them, don't worry about anything. Instead, just know that it's important, it's so crucial for you to have the correct answers. That's what matters the most. Okay, so from that point, we are happy. All right, then of course our t is equal to 9 or our t is equal to negative -6. But in the statement, they say that t should be less than 0, which means your t value must be negative. So now we can just conclude the coordinates of k is -6 is to -6. Bingo, dango, we are done. Any questions? Please feel free to engage on the comment section so that I can see if you have any question. Any question, guys? Are we happy? Great. Looks like we are happy. So now let's proceed to the next question, guys. Let's proceed to the next question. So on the next question, what do we have? Now we are on question number 4. We are given an ugly circle there. Question number 4. We're still on analytical geometry, guys. Don't worry. We're on question number 4 now. So on question number 4, they say in the diagram below, the circle centered at M. Oh my word, there is a center. M is equal to -2/3. Let's see where the center is. Okay, that's the center. Cool. Now it passes through A and C. Okay, it passes through A and C. So when we join those straight lines, we're gonna have a radius, because you know that a line drawn from the center of the circle to the circumference of the circle is always a radius. It's nice. Maths has been always nice. Okay, we are just analyzing. We haven't started answering yet. BA and BC are tangents. Great, which means BA and BC are tangents. So we can literally see according to Euclid geometry. So those 2 points when they meet. So when we are having angles, we can literally see that that can be just creating what we call an isosceles triangle. So those 2 angles might be equal to each other because tans turn from the same point, turn chords from the same point. Hopefully I'm saying it in a proper way, but that's that. Okay, now from that point, now it's just nice to analyze the question before we answer. All right, so now we are told that A and C respectively, and with BC parallel to the y-axis. So BC is parallel to the y-axis. Okay, doesn't matter. Determine the equation of the circle in the form of x minus a squared plus y minus b squared equal r squared. This is easy. 4.1. So we are given x minus a squared plus y minus b squared is equal to r squared. A and B, they are the coordinates of center M. It's always like that. A and B is always the coordinates of the center. So that will be x minus 2. That will be positive 2 squared plus y. That y is positive, so that will be negative 3 squared is equal to r squared. So for us to get r squared, we can substitute with any value. So we can substitute with coordinates of a, which is -1, which is 1 is -1, because they are located on the circle. So we can be able to substitute them. So where there is x, now we have 1 plus 2 all squared plus -1 minus 3 all squared equal to r squared. Okay, then 1 plus 2 squared, 1 plus 2 is 3, 3 squared is 9, plus -1 minus 3, that's -4, -4 squared is equal to 16, 16 plus 9 is equal to 25. Don't be like me, use your cashier calculator. See, I even have mine because it's very important to have your calculator next to you so that you don't do mistakes. So therefore our equation will be x plus 2 squared plus y minus 3 all squared is equal to 25. So this will be our equation. Okay, then write down the coordinates of C. Where is C? Where is C? Oh, there is C, and they say that C is parallel to the y-axis. So what does that mean, and how can we calculate that? So we can see that that C has the same x value, because we can see that when we want to draw a line here, we can literally see, let's see if I can draw a line there. So we can see that this is here. So this is just a straight line here. So which means the value of C here, it has the same y value, because they say that they are parallel to each other. So C already, it's x is to 3. Why? Because they are parallel to each other, which means their y values, they are the same to each other. Okay, so those are the important stuff which is important for everyone to be able to see and to be able to notice there. So now let's answer and let's write down the coordinates of T, and it's only 2 marks, guys. So since we know what is the coordinates of C now will just be, of course, we say that it's going to be 3, because that's in the same line, and for y it's just going to be -2 minus 5. Okay, then we get our 7, -7 there. So the coordinates of C is -7 is to 3. Or someone can say that this is a long process, so you can just say again, if you were not able to see it, but you'll be able to see that the y values is the same. So now we can substitute this c is x is to 3 in this equation here. So where there is x, we put x, then when there is y, we put 3. So here we put 3, then after that we solve for the value of x. So definitely you'll be able to get the same. Negative 2 minus 5 is to 3. The negative 2 minus 5 is just negative 7 is to 3. Then from there, then we are happy. If you are happy and you know, clap your hands. Pa, pa. So this is what? By symmetry. Of course, we can now proceed to the next question. Write down the equation of the tangent of AB. AB. Okay, that's easy. We can see we have a line here from the center. So we need to know what is the gradient of the radii. Okay. Okay, my straight line is not really straight, but it's okay. Sorry. So on 4.3, we start by calculating the gradient of AM. That would be y2 minus y1 divided by x2 minus x1. So that would be what? What is our y2? Because now we are looking at AM so that you can get its gradient. So that should be 3 minus 1. Then we have negative 2 minus 1. So 3 minus 1 is 4. Then 4 divided by negative 2 minus 1, negative 3. So we have our gradient to be negative 4 over 3. But we know that the gradient of AB times the gradient of AM should be equal to negative 1, because this is the gradient of the tangent times the gradient of the radius, which equals to negative 1. Why? Radius, or you can say tangent, let's just say radius, which is always perpendicular to the tangent. We are gonna go to the tan chord theorem. That's where fun is, guys. So we can literally see that's where we have that, and from there we can see that the gradient of AB will just be equal to negative 1 divided by negative 4 over 3, which is just gonna be 3 over 4. So the gradient of AB is just 3 over 4. Then from there, of course, our master equation y minus y1 is equal to mx minus x1, where y1 and x1, they are just the coordinates of any point which is located on the tangent. In this instance, it's a, which is 1 is to negative 1. Then we have y minus 1 equal to our gradient, which is 3 over 4 x minus 1. Then from there, we have y plus 1 equal to 3 over 4 x minus 3 over 4. Then of course, transpose that one, that will be 3 over 4 x minus 3 over 4 minus 1. Then from there we use our calculator, but we know that negative 3 over 4 is the same as negative 0.75 minus 1, that's negative 1.75. But again, we use our calculator, then that y will be equal to 3 over 4 x minus 7 over 4. Then there is our equation of the tangent. So that one was easy and straightforward. Okay, now calculate the length of BC. Why, guys? Why are they like this? This is now easy. It's boring because we can see there is C, and when we're looking at C and B, they have the same coordinate of x, because they are located on the same line. They just have y different values. So we can literally just say our b is, what was our cx value? Our cx value was negative 7 is to y. Okay, so if we substitute this into this equation which we have calculated for the tangent, this is the equation of the tangent of AB, then we'll be able to get the y value of b. So that would be y is equal to 3 over 4 times negative 7 minus 7 over 4. Using your calculator, that would be 0.75, negative 7 minus 7 over 4 there. Then I'm getting negative 7 as well. So the coordinates of b is just negative 7 is to negative 7. Then from there, now we can be able to calculate the distance, because they said what is the length of BC. So now you just say the distance of BC is equal to, of course, x squared x2 minus x1 all squared plus y2 minus y1 squared. Then of course our x values are just the same, negative 7 minus 7 all squared plus negative 7 minus the value of c at y is -5. That's -5 there squared. Then our distance using our nice beautiful calculator, then that should give us 10. Okay, moving forward from that point, 4.5. Determine the equation of the circle centered at A that has both x and y axis as tangent. Oh, that's easy. That's so easy because this is just going to be x minus a as always, all squared, plus y minus b all squared is equal to r squared. Of course, if c and a, sorry, it's centered at a, so that will be x minus 1, sorry, x plus 1 squared, because it was our coordinates of a is what? Let me double check the coordinates of a. I forgot them. It's 1 is to -1, so this is the center now, so that's why you can see we substitute here. It's now negative, then we have y minus, then that y value there is negative, so when it comes it's going to be positive squared, then of course 1 squared, then what would be our r? They said they are located at both the x and y axis of their tangent as tangent, so then definitely that's going to be 1. So therefore our equation will be x minus 1 all squared plus y plus 1 all squared is equal to 1. Then from that point we are happy. Now if another circle with center n and that radius intersects the circle centered at M at two distinct points, determine all possible values of p. Guys, this is easy. I'm just going to give you a hint, and other rest is going to be for your homework, because I need you guys to have something to do. So they intersected 2 points, so it's something like this. So they intersected 2 points, then after that they say determine the value of p. So what is important is just understand that r2 minus r1 is less than our mn. Then from there, this is less than r2 plus r1. Then after that we can just play around. And so it's your homework. It's your homework. You need homework. You need to do it. Then we can see if you were really listening. Okay. Now from that point, now let's proceed to the next question. Guys, toppers, ask us questions in the WhatsApp group. We are here to assist each other. All right.